In this video, I will show you how the perceptron learning rule works, how you can adjust your weight vector as you see data points so that you don't make as many mistakes in the future. The way that the perceptron predicts when it sees a new data point x, it takes the dot product of x with the weights, and then it just looks at the sign. So it can only put things into two categories, +1 or -1, which is just whether that dot product is positive or negative. The way the algorithm works, I'm going to walk you through this, but in pictures, the important lines are 5 and 6, where if it makes a mistake, that equal sign with the squiggle through it just means not equal to. If it makes a mistake, then you see on the next line in 6, it takes the vector and it adds something to it. That's going to take the weight vector or the decision boundary and shift it so that it won't be wrong if it sees that same mistake next time. And hopefully this will transfer a little bit, so if the data point you see next time isn't identical but is similar, it should still not get it wrong. So this is the perceptron situation. After we've seen some data, you have our weight vector in green. You have things that are within 90 degrees of that weight vector. We call those points positive. And the things that are more than 90 degrees are on the negative side. It's easier for, you can think about moving the green weight vector or moving the boundary. The rest of these slides, we just use the boundary because it's easier to visualize. But remember that the decision boundary and the weight vector are two ways of thinking about the same thing. As you move the weight vector, the boundary shifts. And what we want to do is we want to move that boundary so that all of our data points are on the correct side of the line. This is the perceptron error correction procedure. If you read Rosenblatt's paper, he actually talks about it in terms of reinforcement learning, the same way an animal or person might learn. I show you an example, I ask you a question, and if you get it wrong, you know you have to change something. So here's what we do. We get a new data point. You can look at it immediately and say, oh, it's on the red side of the line, which I said was negative a minute ago. But to do that with math, you need to look at that dot product. And so the dot product with the weight vector is going to be negative. So if that data point is from that -1 category, then it's fine. You don't do anything. But if that data point was actually from the positive category, now you have a point that's on the wrong side of the line. So we have to move the line to make sure that all the points are on the correct side. The way we do that, because these things are defined as vectors, we can just add them in. So let me walk you through that. So we want it to be positive. We want to be on the positive side of the line, but we predicted negative. So it came up to the right instead of to the left of our boundary. So we need to move the boundary, which we do by moving the weight vector, which we do by adding or subtracting something to the weight vector. So what are we going to add to it? So what happened was when we saw that data point x, our sign was negative. We were on the wrong side. We want that sign to be positive. So we're going to add something into it so that if we saw the same x again, it would be positive. So it has to be something that's positive when you multiply it by x. So what we do is we add in x. Because when you dot product it with itself, if you go back to the definition of the dot product, you take all those things and you square them, you add them up, you take the square root, that'll take any number and make it positive. It's guaranteed to be positive because of how the dot product works. And we know when we see the new data point, we're going to be doing the dot product over again. And so our update, by being just x itself, next time we're going to have the same thing, this x times w, which we know is negative, and the new part, which is just x, which x times x, the dot product x, is positive. And so if we keep doing this, eventually everything inside that sign is going to be positive. It might not work if we see the data point once. We need to see it 10 times, but eventually that guy will end up on the right side of the line. So if it's positive, you add the vector. But what if it's negative? If it's negative, now you have the opposite problem. So again, we have the sign of our dot product was positive, and we want it to be negative. So we need to make it more negative. We need to say next time we see X, I want that stuff that's inside the sign to go negative. So we have to add something negative so we can subtract that same dot product part. And so we're going to take our weight vector, subtract X, and then next time when you see it, you will make the opposite prediction. When we go back to the code, rather than having a separate case or statement for if it's plus and you pick minus or minus you pick plus, we just always add, but we add the data point X times the label. So if it needs to be more positive, then it's 1, so you add it. If it needs to be more negative, the label's -1, and it subtracts. That's it. It's just, you see the data point. If you are correct, you're correct. You shouldn't mess with anything. If you're wrong, you need to make a change. You need to make it more positive or more negative, so next time you won't make the same mistake. That's all the perceptron